Are we good? Yes. Okay. Hi, everybody. Thanks for coming out. We're going to be talking about the native camera APIs today. I'm Sean McVeigh. It's my associate here, Paul Bernhardt. And let's just dive in. First thing I wanted to do is just sort of get an idea for who we have in the audience. You can just put up your hands. Anybody here a photographer? Yeah. Has anybody used the camera APIs yet? A couple people, okay. Anybody want to do sort of advanced camera stuff, like you want to apply filters to the camera, do augmented reality, things like that? Okay, cool. Video conferencing, I know there were some people looking into doing that kind of stuff. So I'll just move on here. I'm going to try and cover, I'm going to do a bit of review from the last time I presented. We're going to talk about what the hardware is capable of, the devices you have, the playbook, the dev alpha A and B now. We're going to walk through quite a bit of code examples. I wrote 8 examples last week. Going from simple stuff like just here's a viewfinder to advanced stuff like here's how we do face detection and modifying the image buffers, filtering, things like that. If it seems heavy on the C, don't worry. We're going to look at QML and Qt examples later towards the end of the presentation or after the C stuff. Paul's done a couple samples up there. And then we're going to jump into some advanced topics, right? Talking about image processing and things like that, and some other hot topics like rotation and resource sharing. And Q&A may be a bit short in this session because we've got a lot of material to get through. If you can hold your questions to the end, that would be great. Also I believe at noon, I'm going to be sitting in on a round table. So anybody who has questions about anything we talk about in this session, you can come to the round table and we can discuss whatever you want for a whole hour. So that's why I'm not too concerned about maybe running a bit long. So onto the camera hardware. The playbook, these are some specs on the playbook. We've got a 3 megapixel front-facing camera, 5 megapixels on the rear. The preview size, 1024 by 576. We can run 15 frames per second photo preview, 30 frames per second video, up to 1080p. We do compressed video for you. We do MP4. We do up to 16 megabit MP4 video. And we can do photo capture. We don't have burst capture on the playbook yet, but we just do regular still capture, and you can run photos around 2 frames per second or so. And then, of course, we have scene modes, things like zoom, digital zoom. We have auto exposure, et cetera. On the Dev Alpha and the Dev Alpha B, we've got a bit more advanced hardware now. Dev Alpha B, you'll notice I've got some features marked in red. The reason the Dev Alpha B maybe has some features that the original one doesn't is because we've really been focusing our development on newer hardware and not so much on the old one. I know some of our vendors haven't been keeping up with us at the same rate. So things that are different here, we've got an 8 megapixel autofocus camera on Dev Alpha. The screen resolution's up to 1280 by 720 now, so higher preview resolutions. We can go up to 24 frames per second now for photo, and we actually support variable frame rates as well now. So you can specify a min and a max, and we'll run somewhere in there. Same video capabilities, but now on these devices we have burst, right? So you can capture full resolution images at 15 frames per second, and you can implement features like the time warp, time shift stuff that we have in our native BlackBerry 10 photo or camera app. Again, scene modes and such. We have autofocus, manual focus, region and face priority, so you can specify just focus here, only focus on faces. So lots of features, pretty rich API. It's a pretty large API as well, but the docs are fairly good, I find. So hopefully you don't get too lost in there. Also, I'm hoping to get as many samples as I can out there that show how to use all these features. The software stack looks a bit like this. On the OS side, we've got what we call the camera service, which is basically all the device drivers, the interface to the low-level hardware. And in the application side, we've got this library, which is what the camera API lives in, which talks to the camera service and provides you all the necessary high-level primitives. All the other APIs that we have, whether they be HTML5 camera or Air camera or even the Cascades Qt camera, they're all built on top of the native C camera API, so they're all using the same code. There's no private stuff, really. So everything that we're using, you should be able to use as well. And I just want to run through quickly. This is kind of, if you're a hardware person, you might want to know this kind of stuff. We've got a camera sensor there. We get full frame images, raw images out of the sensor. Our image signal processor cleans that up, does noise reduction, rescales, crops, does all of that, sends all the data up into the camera service, which supports the viewfinder window for you. And then up to your application, you can get streams of preview frames, video frames, stills, full resolution still images. And then there's this post-view or review frame, which is, after you take a picture and you want to just show a little thumbnail or something, that's what these are for. So we're going to jump into looking at code right now. We'll look at some of the most basic things we're going to want to do when we're writing a camera app. So maybe we can switch to the device here, just so we can demo. So if you bring up the Viewfinder app here, all this guy does, he opens a viewfinder, displays it on the screen, tap it, and it closes. That's it. So I will walk you through a little bit of what that code looks like. If you can come over to the Mac, that would be great. Hey, there it is. Cool. So what we have here, to get that viewfinder started, we basically, we're doing things like querying what cameras are supported on the platform. So you don't want to hard code always open the front camera, because you may end up on a device that doesn't have a front camera at some point. So we have lots of APIs for querying what the capabilities are, how many devices are supported. There's different ways to query which devices are supported. You can also query like this down here. You can say, I've got a list of features that I'm interested in, like photo and video. What cameras on the platform support photo and video? And you can query that, and you'll get a list back of these cameras can do the things that you're looking for. So it kind of helps you inventory what's available and pick what camera you want to use. Next thing you're going to do is move along. You're going to open the camera. Opening the camera gives you a handle back. And then from there, you're going to use that handle for all future camera function calls, right? So if you need to configure the viewfinder properties, you pass that handle in. You specify a couple of things here, like this is the name of the viewfinder window I want. And is anybody familiar with libscreen? Has anybody looked at the screen APIs in the native platform? Yeah, somewhat. The prerequisites for starting a photo viewfinder are you need to have a window group, and you need to provide a window ID, because that viewfinder gets created by the camera service, and your application needs some way of finding a handle to that window later. So you have to listen actually for screen events that say, there's a new window created in the group that you specified, and then you grab that handle and you can manipulate the window however you want. In Cascades, it's slightly different. They've wrapped all that up into what's called the foreign window control. So foreign window control, there's lots of examples for that out there. A lot of my samples are using foreign window control as well, so it'll show as well how to get through doing it in the Cascades way. So we're going to configure a photo viewfinder. This is the simplest example I have up here. Down below, we've got, here's some more complicated config that you could have done. We could have specified widths and heights, rotations, etc. And then the last thing you're going to do is, you have to also configure photo properties along with the photo viewfinder. They have to match up. So if you're doing a 4:3 aspect ratio viewfinder, you have to also start doing 4:3 aspect pictures. They have to match up before you start a viewfinder. It's a gotcha that you might run into. And then the last thing you're going to do is start the photo viewfinder. So when you're starting the viewfinder, you can specify, I want this viewfinder callback to be fired every time a preview frame is available. This is how you get access to buffers from the camera service. There's also an event mode interface to these rather than callbacks if you're not comfortable working with threaded callbacks and all the synchronization primitives that go along with that. So the two callbacks supported by the viewfinder are viewfinder callback, which gives you preview frames, and the status callback, which basically just tells you things that the camera service is doing. It'll say things like the autofocus algorithm changed, we've locked focus here, resources are going to be taken away, the camera shut down. It tells you things like that. So that's basically it to get a viewfinder started. And then to stop the viewfinder, there's an equivalent function called camera stop viewfinder, and then you can close the camera handle down. And that's the guts of how a viewfinder sample works. All of this code that I'm showing today, I'm going to put it all up on GitHub so you guys can look through it again later. I just want to kind of walk through it a little bit so that you understand what was in my head when I wrote this. Okay, we can switch back to the PC there. So again, yeah, these are the sorts of things we're doing. We're starting a viewfinder, et cetera. I think I just walked through that. Next one up, actually this time I will go through the slides first, then we'll show the code. Video recording is very similar to, it's pretty much one step above starting a viewfinder because the video recorder actually uses the same buffers that are coming out of the preview stream. So you're going to basically start up a viewfinder, tell it to start recording video, and it does so with all the preview frames. It registers its own callback and pulls all the frames in and encodes them for you. Video viewfinder mode, we have two different viewfinder modes. There's a photo mode, which allows image capture, and then there's a video mode, which doesn't allow image capture, but works at a higher frame rate, higher resolution. So if you're going to want to take pictures and then take video, you're going to want to switch viewfinder modes. You have to shut down the viewfinder, start it up again in a different mode. When you're recording as well, you're going to want to be monitoring for any conditions that happen that would indicate that there was an error. You know, we're out of disk space, or the file got too big and was truncated. I think there's a 4 gig limit right now, but we're working on getting rid of that, so it should be good. And resource monitoring as well. So if there is a higher priority task in the system, like another app comes to the foreground that needs all those video resources, it's going to steal it from your app that's in the background, and you'll be told about that. The viewfinder's shutting down, and then you'll know when your app comes back to the foreground, you're going to have to start it again. So if you want to show this demo, this is a video recording demo. Can we go to the device here? So again, just a viewfinder. If you tap the screen, it beeps and starts recording video. You tap it again, beep, it stops. I guess there's no sounds, but
Yep, looks like.
But anyways, pretty basic. If you want to jump over to the Mac here, take a look at the code. What are we into? Video, record video. Oh, I don't. Yes, I do have that one up.
I have audio up on your phone device.
Oh, okay, cool.
Thanks.
So very similar. We're starting up the viewfinder again, querying the supported cameras and such. We're going to set up, this time we're setting up video viewfinder properties. Similar set of properties exist. You can configure resolutions. In terms of knowing what resolutions are available, there's APIs where you can query what sort of resolutions are supported, and other capabilities like that. Get the viewfinder started, and then when we want to start recording video, what we're going to do, if someone taps on the screen, we are going to open the camera roll, get a file name to start recording, and then we're going to play a sound that says we're starting recording, start recording the video, and when it's done, similarly, we're calling camera stop video. So pretty basic. There's two functions to start and stop recording. And again, you'll see you can attach callbacks into those, so you can still receive the frames that are being recorded if you want to do any image processing or hunting through them for any sort of data. I'm going to touch really briefly right now on the shutter sound policy. I know there's been some questions about this in the past. Everybody hates when you've got a camera on your phone and it makes this really loud shutter sound. We're not forcing you to put a shutter sound in, but it's all in the NDK developer agreement. This should all be clarified, but you have to just be aware that we don't play shutter sounds for you. It's your responsibility to play shutter sounds, and you have to comply with the legal requirements of any of the countries that you're selling your apps in. So for example, if you're in Japan and your app is being sold in Japan, it's, I believe, illegal to have a camera app that doesn't make sounds in Japan. So be aware of that, do your due diligence, find out. There just has to be some sort of sound that lets people know they're being recorded. But I know some people have asked, well, what if I want to write a camera for taking pictures in a classical music concert or something? I don't want to make sounds. Well, if that's what the application is supposed to do, then as long as it says that this app doesn't make sounds, blah, 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 then you're good to go. So a little bit of clarification. It's still a bit fuzzy, but it's your responsibility to sort most of that out. So if we want to jump back to the presentation here. The next one we're going to look at is image capture. So taking a photo, very similar to the video one, very similar to the viewfinder one. It's just built on top of it. Again, we start a viewfinder. There's a function called camera take photo, which again, you can specify, I want these callbacks. Is anybody familiar with the Android APIs? Has everybody used the Android camera? No? Okay, it's modeled loosely around that, so it would look familiar to you if you're used to using that. So you're going to call camera take photo, you're going to get a buffer back. It's your responsibility to save the photo. So you can choose to save it in your sandbox, you can save it on the camera roll, you can not save it, you can post it right to the web, do whatever you need to do. You're just going to be handed a buffer. Here's a pointer to the data, this is a JPEG buffer, do with it what you wish. So if you want to take a look here, back to the device. This is our camera take picture example. Tap the screen and it takes a picture. It's pretty basic. And then I will show you the code for that. Again, we've got setup code, shutter callback right there with the comment that says whenever the shutter fires, we're going to play a sound. The still callback, this is the one that I mentioned. When you're handed a buffer, you get to decide what to do with it. So you can see we've been handed a camera buffer. We're going to open the camera roll. Ooh, there's a laser on this. We're going to open the camera roll. And then save the file. We're just going to do a write to file, and it's done. That's how you save photos. How do you take a picture? This is what camera take photo looks like. So you've got several callbacks that you can register when you take a photo. So there's a shutter callback, which will fire when the hardware tells us it has captured a photo. That's when you play your sound. Then there's a couple other ones in there for review frames and such, but the still callback is the one you'll be interested in. That function will get invoked when the JPEG is ready for you to save. I should mention as well that we don't support only JPEG. We can do raw photo capture. There's, I believe, a Bayer format as well you can use. So we have a fairly descriptive Bayer format that explains how many bits it is, what the color component ordering is, and so on and so forth. So if you're into doing your own debayering algorithms, you think you can do better than TI or whoever may be doing it, then go nuts. So we could switch back over to the presentation. Very similar to taking a photo is taking a burst capture. So if you want to implement something that's going to capture multiple frames and then let the user select the one they're happiest with, or you want to automatically select the one you're happy with, or you want to run the burst all the time so that it's always capturing photos, you can keep a circular buffer going so that you can implement negative shutter lag. So if you have a buffer that's buffered, say 3 seconds worth of photos and someone hits the shutter, you can actually go back in time to pick what you think they might have wanted to take or let them choose, so on and so forth. So very similar, you're going to configure the viewfinder for burst mode. You're going to call camera take burst to take a fixed length burst. So you can say I want only a 10 frame burst. It will run. The API is very similar to take photo. It has the same number of callbacks. It will just invoke a shutter callback 10 times. It'll invoke the still callback 10 times, so on and so forth. The only thing you're going to want to be aware of is handling the data. You're not going to want to take your exact same callback that was taking the buffer and saving it to disk and try and run that at 15 frames per second. It may not be able to keep up. You're probably going to want to just buffer the data. So when you're handed a camera buffer, malloc one of the same size, throw it in there. When the burst is finished, go through that list of buffers, save them all to disk, do whatever you want with them. That's my recommendation if you need high performance and many frames, because these are full resolution images we're capturing here, so 8 megapixels. And writing those out to disk in real time may not work for you. And if you... I'm not going to show you the sample of that. It looks basically the same as take picture. It plays the shutter 5 times when it runs. But if you switch over to the Mac here, I will show you what is different. What is different is when we are taking a burst right here. It looks a lot like the camera take photo API. You pass in your camera handle. Say I want five. That's a 5-shot burst I want. That's the shutter callback I want to fire every time there's a capture. That's the still callback I want to fire. You don't have to play a shutter sound on every frame if you're going at 15 frames per second. Do whatever seems reasonable to you. You may only do every other one or every 5th one. It's just a noise to let the user know that they're capturing burst. Or if you're trying to do an always bursting implementation, you probably don't want to bother playing that sound at all. You probably just want to play the sound when they capture at the end. So it's entirely up to you how you want to implement that. It's whatever makes sense for your app. We want your apps to make sense to the users, right? So there is another way to invoke this. If you want to take bursts forever, like I mentioned, you don't want to just do a fixed 5-frame burst. You can call camera start burst, which looks very similar to this, only it doesn't have that argument for how many frames you want. So you can call start burst, very similar to how video recordings works. So start burst, and then when you're done, camera stop burst, and it will stop bursting. And I will show you really briefly what I've got up here for a stills callback. So this is what I'm doing. I'm saying, if I've received a JPEG buffer, I'm going to increment my burst count. I'm going to malloc a new buffer that's the same size as the frame that's coming in. I'm going to do a, where is it? Malloc it, where's buffers, mem copy right there. I'm going to copy the data that was given to me by the camera into one of my buffers of that size. I'm going to bump my counter up, and then when I'm finished capturing all my photos, what I'm going to do is just loop through that list and save them all at the end, right? So I'm going to go through how many frames did I capture. I'm going to open a file for each of them, save them all, free the buffer, move on. So it's again, the sample code will be there if you want to see how that's implemented. I'm sure you won't have any problems getting through that sort of thing. So if we want to go back to the slides, we are going to be talking about Flash next. And the reason I'm going through all these examples, each one of these examples is going to, in the code, there's lots of comments in there. It's going to detail some of the pitfalls and some of the gotchas that you're going to have to be aware of with some of the different features. So Flash, same as the photo example. I believe I'm now switching over to Cascades now, though. So I implemented this one in C++ in Cascades. We can do a demo of this one, actually. But you're basically querying the Flash capabilities, find out what Flash modes are available. So if you start the rear camera, or the front camera first, you'll notice we grayed out the box up there. So the code actually queried what Flash modes are available, and it says, oh, there aren't any, because we're on the front-facing camera, there's no Flash. If you're on the rear camera, you'll notice that the drop-down box is, it's not a drop-down box, actually, you can tap it, so he can switch Flash, if you take a picture with Flash on. Takes a picture, and there's a beep. That beep, if Flash is off, there's no beep. So that beep, I put it in, I'm actually checking in the EXIF data that comes back with the photo. I'm saying, I'm going to scan through the EXIF data. Does it indicate that the Flash fired? I'm going to play a beep. So you can scan through the metadata that way to find out what sort of things happen when you're taking photo. So if you want to jump over to the laptop here, we are looking at Flash photo. So this will all look, it's all in C++, but all of the sort of start camera functions are all going to look very familiar. So on start front camera, we're going to call create viewfinder, on start rear, create viewfinder, and then the create viewfinder function looks like this. Again, we're just setting up some viewfinder properties. We're doing a bunch of UI stuff, and then we're going to call configure the Flash. Can we use the Flash? If we can use the Flash, configure the Flash, so on and so forth. So it's very similar to the C code, just peppered with a lot of Cascades UI stuff. What happens when we take a photo? We are in the still callback right here. I've received the buffer. I'm going to open a file. I'm going to save it, but before I do so, I'm calling that function check metadata. That check metadata is the one that I mentioned is going to actually play that beep. So this thing is pulling out the EXIF data from the JPEG. We have a pointer in all of our camera buffers that says here's where the metadata is, so you can follow that pointer, find out that it's an EXIF packet in metadata. You can parse it using libexif. There may be XMP data as well, so you can parse that using libxmp or whatever XML parser you like. We actually provide face detection coordinates using XMP, so you might see that later. And again, right down here, I'm just querying for the Flash tag here. And if I see that the Flash value indicates that the Flash was fired, I'm playing a sound. So it's just an example here of how you can use the metadata to your advantage if you need to, right? So we can move on to the next one, I guess. The other thing I want to mention about Flash is we're usually operating in what's called zero shutter lag mode. which means that when you ask for a picture to be taken, you're going to get the photo that is on the viewfinder right now, or as close as reasonably possible to it. When the flash is fired, of course, there's going to be some lag introduced because we can't run in zero shutter lag mode because, of course, the flash wasn't firing when that viewfinder frame was being displayed. So just be aware that this will change the capture characteristics of the data pipeline. There's also AF assist, which may be configured so the LED will turn on to allow the focus algorithm to adjust, and then it will maybe pre-flash and then flash and fire. So it can take a second or two sometimes to take a photo if all of these flash features are enabled. So just be aware of that. Zoom and scene modes is the next sample I did here. So we support zoom ranges. You can query what the range is. You can query the logical settings. So you can say, I want to zoom between, I think, 0 and 40 are the steps we've defined. But what does that translate into? You can also query the physical capabilities of the camera to find out what the actual zoom range is, from 1 times to 5 times or 1 times to 3 times. You can query these things as well. Applying the zoom, there's 2 ways to apply zoom. There's a function called camera set zoom, which just applies the zoom setting you want. You can also specify when you're starting a viewfinder. You can also say, I want to start the viewfinder, but I want it to be zoomed into this level when it starts. So there's 2 ways to apply that. And then scene modes as well. We're just going to query what scene modes are available, how to apply them, and so on and so forth. So if we want to show a demo of this on the device. So you'll see if he starts the rear camera here. So he's got a zoom slider on the left that I did. So that does that. You can pick different scene modes up top there. So we've queried what are the available scene modes. You can toggle between them. That's just going to call camera set scene mode to change the scene modes. One thing I want to mention about scene modes, actually, some of the scene modes may override some of your settings. We tried as much as possible to make sure that the camera behaves as you want it to behave. So whatever you specify, we're going to do, except in the case of scene modes occasionally. So you might switch to a night scene mode, for example, and for it to maintain proper exposure, it may slow the frame rate down on you. So I think that's the only one that I'm aware of that really modifies things without really telling you that they've been changed. So keep that in mind. If you actually stop and switch over to, say, the front camera here, you'll notice it's zoomed way in because I made this zoom bar be persistent. So that's an example of how you start the viewfinder with the zoom applied already. So, and he takes a picture of himself. Fantastic. So if you want to jump over here, I can show you briefly what we've got for scene and zoom. Lots of code in this. So when we create a viewfinder or when I go to display, take picture, camera zoom level, min. On zoom changed. So this is the handler here for when someone modifies that Cascades slider. I've got a signal in a slot hooked up. It'll call this function. It'll get the value from the slider and will apply camera set zoom on that value. On scene change, same thing. If you'll see down below, I'm calling camera set scene mode. That's all you need to do to change scene modes. You just pass the value in. There's an enum for all the scene modes, and you can also query the list of available scene modes, which is done right here, actually. Update scene list. This guy's going to call camera get scene modes. It's going to return an array of available scene modes based on what viewfinder mode you're in. You cannot query scene modes before you've got a viewfinder started, and that's because in video mode or photo mode, we may have different subsets of available scene modes. So say action mode is available in video, but not photo, for example. That's probably not true. I think that they are both available, but there may be some that are supported in one viewfinder mode, but not the other. So good to keep that in mind. So anytime you need to display a list or find out what scene modes are available, you query them after you've started the viewfinder. That's it for that one. If we go back to the presentation, we can talk about focusing. This is a fun demo. Now that we have an autofocus camera, everything gets way more complicated or way more flexible, depending on how you wish to look at it. On the Playbook, we've got an EDOF camera, same on the front-facing camera on this device, so you don't have to really worry about focusing, but then again, you also may not have everything in focus all the time, so advantages of having an autofocus camera. Again, similar recipe, you're going to query what kind of capabilities there are, so there's a function you can call that says, give me what focus modes are available. You can put them into a list, however you want to choose them. The major modes are manual focus, so we give you control over focus if you want to set it wherever you want. There are single cycle autofocus modes where you can say focus once and it will focus and stop. There's continuous autofocus modes where it will always try to keep focusing whenever you pan the camera, it'll continue trying to focus on the subject. And then 1, 2, 3, those are the major modes. The minor modes in there are basically scoping. So you can say, I'm in a single cycle autofocus mode, but I want to only focus on this area of the screen up here. So you can scope it that way. You can say, I want to focus on this region. You can also specify the algorithm priority mode. So you can say, I want to focus only on faces, and it will prioritize faces that it finds in the scene, and I'll try and focus on those instead. So it's very powerful. There's lots of modes available, and I've exposed everything that I can to you guys via the APIs. Status monitoring as well. If you have a status callback hooked up, which you should probably if you're doing autofocus, it will tell you whenever the focus state changes. It'll say the focus is searching, it's locked, we lost focus, etc. And it also can tell you where the coordinates are that it focused. So you can implement something like a little visual indicator that says I focused here, I focused there, and so on. You can lock focus as well, and then manual controls. Similar to Zoom, you just say camera set manual focus step and say I want to focus on this range between 0 and 100, so you can adjust it. If you want to see this demo, Paul will show you.
Great.
So you'll notice this is the rear-facing camera here.
Yep.
What are you doing, Paul? You're in continuous autofocus mode right now. So it's always going to try and focus on whatever it sees. If you switch to one of the single modes, it'll be auto SAF, 2 above that. Bam. So you notice I've given him a button now for refocus, because single cycle focus only runs once and stops. So if you want to refocus, you just call camera set focus mode again. You reapply that mode, and it will rerun a cycle. So you'll see right there at refocus. So if you point it out here at these guys, you can try touching the screen. So he's doing touch to focus here. This is applying a region saying I want to focus there, and then it goes off and does its work, and then comes back and says I focused there. These are the coordinates. So this is kind of neat stuff. You can also use this sort of stuff in a closed loop. If you want to implement your own focus algorithms, you can monitor the scene, do your own image processing, decide how you want to focus on things. If you're doing your own face detection, say you've got more than face detection, say you've got face recognition or object recognition, and you only want to focus on certain sorts of objects, then you can always be monitoring the image stream and then apply your own focus settings. So you can say focus on this region here because I know this is where there's a person standing, or so on and so forth. Or you could say focus only on the top half of the screen if you know the bottom half is noisy or something, or any number of things you can do. Also similar, we have exposure controls. We do run an auto exposure algorithm all the time, but you can lock it off, and you can also scope it by region as well. You can say only focus on or only expose in this region of the screen. So if you have a bright scene with a sky and then a bunch of people standing down here, or something that's backlit, you can actually tap on the face and say, I only want you to expose in this area, and it'll adjust for that. So some pretty cool stuff there. How are we doing for time here? We are halfway or more.
Halfway.
So again, we've got, let me just see what I've got. On focus mode change. So here, for example, is an example of how we do manual focus. So again, we're calling camera set manual focus step to adjust that with the slider. If the focus mode is changed, the user decides a different mode. What we're going to do is call camera set focus mode. That's how you change the major modes of the camera focus algorithms. How do you query what are supported focus modes? You, again, call this function camera get focus modes. It's very similar. We have functions called camera get scene modes, get focus modes, get flash modes, etc. They return lists of available modes that you can pick from and do whatever you want with them. So those are the main ones in here to look at. Again, and then I've got these touch to focus code here. So again, all this is going to be on GitHub. You can look at all of this offline and ask me questions, and I can clarify things for you. But the intent is that you can take this code and start writing an app using it. Okay. So we'll switch back over to our presentation here. And this is a cool one. You're going to like this one. So face detection is pretty cool. So face detection on our device is implemented in the preview stream. So as part of the viewfinder data, when you're getting the images, you're also getting metadata if you've turned it on. There's a function to turn on face detection. So you'll receive a preview frame, and you'll also receive metadata along with it. You can parse that and say, oh, I've found XMP data here in the metadata, and buried inside that XMP data is our list of faces that we detected in the scene. It's all done by the hardware, it detects the faces, and we're exposing that to you. So you can, again, query the capabilities. Does this camera support face detection? Turn them on, and then hunt through the XMP data using libxmp, which is on the platform, or whatever XML parser you're happiest with. Libxmp, I understand, is a little bit unwieldy from the guy who ported it for us. So what am I looking for here? Which one is this? This is the faces. Oh, yes, I've merged this example with a different example. So along with doing metadata and face detection, I'm also at the same time going to be talking about inline filtering in the camera. So if you want to implement any effects on the viewfinder frames, you can register using event mode this time. We're not doing read-write callbacks. We had to add event mode interfaces. And that's the method you're going to access buffers in a read-write mode. So what we have a buffer coming right out of the ISP, the signal processor on the camera. If you have a filter hooked up, the data will be passed to your filter first. If you don't have a filter hooked up, it goes right to the callbacks to the readers at the end. So for example, this guy at the bottom would be the viewfinder inside the camera service. This guy would be one of your callbacks. This could be the video recorder. We support multiple outputs of the image pipeline. But we only support one filter in the middle. And this filter is going to rate limit everything. So if your filter takes 100 milliseconds to process a frame, everything else after it is going to slow down to 10 frames per second, right? So you want to probably do some quick image processing if you care about frame rates. And again, all the data that comes out of the filter is sent to the same list of callbacks. So this is how you can apply a filter, have it appear on screen, and also appear in the recorded video stream, et cetera, et cetera. So the demo I'm going to show you, or Paul's going to show you, this is a cool one, I like it. This is what I call the witness protection camera. So what I'm doing here is I'm running through the XMP data. I'm finding that there's a face there. I'm only looking at the first face it finds, and then I'm applying, there we are. Hello. I'm applying a pixelating filter over top of the data. Then it gets sent back into the camera service, gets displayed on the viewfinder. This is also a video recorder, so if he taps on it, it'll start recording a video. And this effect will show up in the video as well. So this is how you can apply inline effects to your videos, to your viewfinders, et cetera. So pretty basic example. All I'm doing is blurring the screen, but there's no reason you can't insert other objects in the screen, data overlays, modify the exposure, do whatever you want, right? You can do your own sharpening filters, apply any kind of filters you want. It's pretty cool stuff. And the video's done. If we had a video player on this device, I would show you the video just to prove that it did do that. But you can download all these samples. They will be up on GitHub. I just have to work over the details of getting them posted. So if we switch over to the Mac, I can show you what event-based stuff looks like. So we've jumped back to C here. This is the XMP stuff, which isn't very pretty. So you'll notice as part of the viewfinder callback, which is right down below it, every time I receive a, it's not a callback this time. I'm in an event loop. This guy is going to, yes, so for event mode interface to the camera, there are 4 functions you care about. There's enable an event. So you're going to go off, create a SIG event, which is pretty standard QNX stuff. There's tons of demos, examples of how to create a channel, a connection, and a signal attached to it. You're going to hand that SIG event over to the camera API. You're going to say, I want to enable the viewfinder event. I want it in read-write mode. That's important if you want to filter stuff. It's going to hand you back a key, which you can use to detach it later or receive buffers from it. And you're going to hand it your SIG event that you want it to fire every time a frame becomes available. So what it's going to do then is it's going to go into this loop of just receiving a pulse. Every time it receives a pulse, that means a new frame's available. We're going to call get viewfinder buffers. It gives you an input buffer and an output buffer. And then I'm going to call this applied blur function, which is just doing the pixelating for me. It goes through, looks at the metadata, finds out where to blur, does the blurring, comes back. When it's done, we return both buffers to the camera service. So that's basically how event mode stuff. And when we're done, when we're cleaning up, we call disable event. So there's 4 steps to running things in event mode. Why would you want to run things in event mode versus callback mode? I actually have a slide that covers that shortly, so we'll get to it in a moment. That's the important stuff to show you in here. I'm not going to necessarily jump into anything else. But the XMP data is, here it is. Parsing the XMP stuff there's quite a lot of overhead involved with it. So it's good to have a sample. I just asked for a sample from the guy that sits next to me at work who ported libxmp. So pretty easy. OK, we can jump back over to the presentation. And I believe we're going to be ready for Paul to take over.
All right. So, I mean, the stuff we've been talking about so far, all the examples have been kind of at the with the C camera API. And we've been doing stuff in Cascades with like building your own foreign window control or using screen API and stuff like that. But what if you don't really want to use the C API? What are your options? So there's a couple different ways to interact with the camera. You can use Cascades, and in there you can choose, there's some things you can do at the QML layer with JavaScript. Some things you have to go down into the C++ layer. You can also use the invocation framework to do a whole bunch of camera stuff. Or I mean, obviously you can use all the C++ stuff we've already been talking about. So I'm just going to talk a little bit about when it's appropriate to use each layer, what kind of trade-offs you're making, and at the end we're going to talk a bit about, what if you want to stay at a high level as possible, what trade-offs you're making. So
We've got about 15 minutes.
yeah, we don't have a lot of time, so we're going to go through this quickly. This is what you can do in QML. You can do basic stuff purely in QML and JavaScript. So you can lay out the camera, like put it where you want on the screen, combine it with other Cascades controls, stuff like that. You can set up and pick which camera you want to use. You can actually start the viewfinder, and you can take a photo. So you can do a whole bunch of stuff in QML. It's a really good starting point before actually diving down into the lower level Qt APIs. But if you find that you can do everything you need to in QML, you probably don't need to actually be building the camera stuff into your app. You probably want to use the invocation framework to take advantage of the actual camera card to do more stuff. I'm not really going to talk about the invocation framework too much. If you're interested in it at all, and I very much think you should be, go to Jam 20. That's happening later today. They're going to go into all the detail you need for invocation framework. All right. So we probably don't need to show off this demo. This is just the viewfinder built in QML. But this is the actual QML you need. So you can see you have just your basic page. You have a camera component. You have to open it. The first time you can do this is when the onCreationComplete method's fired in JavaScript. So you just call camera open, pick whichever camera you want to use. I think it gives you the rear by default, but you probably want to specify it. Once the camera open is actually open, this is asynchronous. You get this on camera opened signal back, so then you can start the viewfinder. Once the viewfinder's started, you can do whatever you want. So in this case, if you touch the screen, it will take a picture. This little Boolean here is just so you're only taking one picture at a time, because otherwise if you touch the screen, you'd get like 4 or 5 pictures trying to take all at once, and that doesn't really work. Once you call this capture photo method, this actually takes a picture and saves it out to the file system for you. And you get this on photo saved event back. I think you get the path with that as well, but from there you can do what you want with it. So Qt APIs. Again, you probably still want to use QML to lay everything out. You don't have to, though, just like all the Cascade stuff. You can build it in the C++ layer if you would like to. But this is where you'll be doing like the real image work, like processing preview buffers or applying effects to final images, stuff like that. Like I said, it's still really easy to integrate with the rest of the Cascades application. But if you're doing things like just manipulating a single JPEG you're taking, like you're applying effects to it afterwards or something like that, you still may not need to actually build the camera API into your application. You might want to just invoke the card, get the image when it's done, and then apply your effects after that. So that's just something to be aware of. So now we're going to do a quick demo. Yeah, I just want to launch the barcode demo. So this is just a little barcode scanner that I wrote. Yeah, that will probably work. There you go. So just scanned a little 1D barcode, and I will now show you how we did that. If you want to switch back to the presentation. So there is actually a barcode scanner, a barcode decoder component built into the platform. You're totally welcome to use that. But if you decide you want to do something else, maybe your own custom barcode format, or you want to play with something else like that, the zebra crossing library is actually built into the platform. That's a very popular barcode scanning library, and you can access that. So this is how you set up the camera in Qt. You'll want to first connect up to a couple signals. You want to connect to the camera open signal. And in this case, I'm just going to talk about taking the actual preview frame you get from the camera. So we're going to connect to the preview frame available method. And then open the camera. So this method, this is asynchronous. So once you've connected everything up, you call this camera open function. You can't really do anything else with the camera object until you get the signal back. So you call this, and then when you get your on-camera opened signal, then you can do what you need to do. So first thing you want to do is probably set up the camera a little bit. This is how you do it in Qt. You create a new camera settings object. Then you get the settings from your camera, and that'll populate it with whatever the defaults are for your camera. From there, you can set whatever camera mode you want. I'm pretty sure it does photo by default, but maybe we're going to set the autofocus mode to be a certain thing, and then apply the settings back. From there, if you're doing what I'm going to show you, is, by processing preview buffers, you want to add your preview buffers to the camera. You need to have a preview buffer. You need at least one for each signal you have on it, but you probably want to have two just to get some double buffering going on, because it will cycle through each buffer and it'll make your app go faster. So you probably want two going on here. Once you get your preview frame, you get like the size, the width, the height, the stride of the preview frame. This is in, by default, it's the NV12 format. I don't know if you can get, how easy it is to get the other formats, but you get an NV12, which is really convenient for barcode decoding. You can basically just take the first part of the preview buffer and throw it into the barcode, the zebra crossing library, and it decodes it for you. That's just barcode decoding, but the important part of this preview buffer thing here is the line at the bottom, camera add preview buffer. You have to put your preview buffer back. If you don't, you just run out of buffers and your app will stop working. So no matter what happens in the preview buffer, in your preview frame available method, make sure you put your buffer back or it's going to stop working quite quickly. So that's just a little bit about how to do a couple things in Qt. You can basically do the stuff we were talking about in the C layer in the Qt layer as well. So I'm not going to go through everything, but there are a couple trade-offs depending on what you're doing. So obviously QML, very high level. It's really easy to lay stuff out, really easy to do stuff, JavaScript, but you can't do very much with it. Obviously you're not going to do high intensity image manipulation in JavaScript. That's crazy. So you probably want to just use QML to lay your stuff out. C, it's very low level, but it's very powerful. It's going to be the fastest. It's going to be, it's really nice if you have a library that works in C already. You can just use these APIs. Qt's higher level, still very powerful. You can do basically the same stuff, but it's not a big performance hit, but all the Qt stuff is built on top of the C APIs, so there is a little bit of penalty you're paying there. Also, in the preview buffers, they actually get copied from the C buffers into a new one for Qt. So there you're actually paying a more substantial penalty. May not matter to you, it depends exactly what you're doing, but that'll be a bit of a performance hit. The other thing, it's not really an issue now, but C may get APIs first, again, just because they're built, the APIs are built in C, and then the Qt layer implements them. So it's possible that something will get implemented in C, and then it just won't make it in time to be released for some version of the SDK. It won't get a Qt equivalent, but I don't think that's happened yet. The other thing is kind of the opposite. Higher level features may only really make sense in the higher levels. For example, when I went through the QML example, you can take a photo from right there, and that's it. Like, you don't get the option of getting the JPEG and writing it out to a file or anything. It just takes the file for you, or takes the picture for you. That doesn't really make sense at a lower level necessarily. So sometimes there's going to be maybe higher level stuff that you can only do at the higher level, or it's done for you. I mean, you can probably still do it yourself. It's just not necessarily as easy. All right, so I had to rush through that quickly. Hopefully that made sense.
Thank you.
Hand it back to Sean.
So I'm going to try and run through this in like 5 minutes because we're running out of time here. We're already kind of over time. Advanced topics. I don't really have a lot of time to talk about augmented reality. The only things I can really tell you are things you're going to want to know to implement this stuff. You can retrieve knowledge about the scene or the physical camera properties. You can find out, what's the focal length on the camera, what's the field of view, all these sorts of things that you may need if you're implementing, say, panorama or any of these other sort of image processing algorithms that depend on that stuff. Knowledge about the scene would be buffers. You can get the buffers from the camera, do your image processing, detect things in the scene, whatever you may need to do. You can extract image elements from the buffers, composite them into your own scene, do whatever you need to do. Composite them the other way using filters, anything like that. Do overlays, throw some information on the screen, about what you see in the screen, in the scene, things like that. Video encoding is another advanced topic here. So when we launched the APIs for Playbook and for the original BB10 beta, we didn't have access to the encoder directly. You could only save MP4s to a file. So I've gone and added this like last week or the week before. You can now register, instead of recording video, you can encode video, and it gives you callbacks at the end of the video encoding graph. So this is hardware encoded buffers. You can take them, stream them across the web, do whatever you want. We just hand you the buffers as they come out of the video encoder. So again, and audio and video are available there. So I don't have samples for using this yet, but we'll get to that sometime in the future. I will promise to deliver that. Camera roll. You'll notice that when I mention you have to save files somewhere, you have to decide where you're going to save them. If you're saving them in your sandbox or wherever, you pick whatever file names you want, do it however you want. If you want to save files into the camera roll, which is in the shared/camera folder, you're going to need access shared as a capability in your bar descriptor, and you're going to want to use this convenience wrapper called camera roll photo open, which basically hands you back an FD. It basically finds a unique number, the next number that's going to be in the camera roll. It'll be image underscore 00001, 2, 3, 4, blah, blah, blah. It makes sure that you're not overwriting files in the camera roll, and it's always incrementing for you. So that's how you save photos to the camera roll. You're free to save files to the camera roll with whatever name you want, but beware, you may be overwriting somebody else's files, and so on and so forth. This is a convenience for you to be able to interop with how the native apps work. Rotation, oh geez, I wish I had more time to talk about this. I'll basically touch on this, I'll give you the 1-minute overview of rotation. I actually have a 20-page slide deck for rotation that I use at work, and it's still not enough. People are confused. Basically, I want to just stress that there are 2 ways of doing image rotation. The first way is actually the buffers that come out of the camera. If the camera is installed sideways in a device, you're going to see sideways buffers. On most of our platforms, we support physically rotating those buffers to deliver them to you in a portrait buffer layout. So instead of a 1280 by 720 buffer, you can get a 720 by 1280 buffer, and the images would be upright if you're holding a phone, for example. The second way to do rotation is to just rotate the buffer when you display it on the screen. So apply a Q transform or a screen window rotation, for example. That's how you can line those things back up. I'm not going to talk about that too much. I'm going to show you the example of what I was just talking about. So every camera sensor is always a landscape sensor, physically. 0, 1, 2, 3, that's just the first pixels top left, and they go from there to the right. That's just that nomenclature. This camera in a phone is installed sideways, 90 degrees. If we're taking a picture of this goose here, this is what the goose looks like in the buffer. If we've asked for a camera buffer rotation of 270 degrees, for example, which is the opposite of 90 degrees, which is the installed native orientation, that's always going to be a supported value for rotation. You're going to get a buffer that looks like that. If you try and display it on the screen, it's going to be sideways. If you ask for 0 degrees rotation, you're going to get the buffer upright like so. It can be displayed on the screen without any rotation. So to actually display these things, the first one we would rotate it on the screen 90 degrees. The other one, don't have to rotate it. So I'm going to try and get some more information about that online, maybe a good sample that shows all the use cases for that. But I know people have been asking questions about that, and I've answered some very detailed forum questions about it. The API docs go into it in quite a bit of detail. Resource sharing I'm not going to really talk about here. There's a bit of example of it in some of my samples that I showed today. Just basically know that other high priority apps may sometimes need to take away contentious resources like viewfinder buffers or video encoders or so on and so forth. And that's basically driven by what app did the user put in the foreground. If they've put your camera app in the background and put some other app in the foreground that needs those resources, it's going to steal them from you. It's going to unmap them from your app. You're going to crash unless you use the mechanism that we provide that lets the camera service notify you that it's about to steal all your buffers. So you can stop using them and clean up, and then it will steal them all away from you. Events versus callbacks, I don't really have a whole lot of time to talk about this, but I showed you the example event mode stuff. Callbacks run in their own thread, so you just have to be aware of synchronization issues there. Events, you can run them in a single event loop, like along with your BPS events, or, well, maybe it's not maybe integrated in BPS yet, but all of your screen events, et cetera, et cetera. You can have one tight event loop that's handling all events for your game or whatever you're implementing. It's mostly game guys that like to have one single thread so they can control things better. And again, there's example code in one of those samples that shows how to set up an event. But again, you're just going to set up a pulse. The blue code is code you're going to have to provide. You're going to call camera enable viewfinder event to enable it. You're going to go into a message receive loop. You're going to receive it. When you receive the pulse, get your buffers. When you're done with it, return the buffers. Again, that's in the sample. Image processing, not much to talk about here. I just wanted to throw out some examples of algorithms you may want to implement if you're looking to do more advanced cameras, right? So you may want to implement some anti-shake, detect motion vectors, et cetera. Only take pictures when someone smiles, do head tracking, face recognition, barcode scanning, et cetera. So lots of advanced things you can do with the camera. Image processing considerations, there's the color spaces to be aware of. We're actually doing RGB now as well. We can provide RGB buffers if you're using a video viewfinder. But I believe the restriction is you can't then display the viewfinder at the same time. Like, you'll have to display it yourself. RGB mode is mostly for if you want to take the buffers and do something else with them. Yeah, that's about all I want to talk about there. Okay, so I think we're basically out of time. I think we're going to be kicked out of this room anytime. Oh, 12, bang, 10:30, exactly.
That's how we roll.
So questions, I don't really have any time for them right now, but at 12 o'clock you can come find me in the lunchroom for a whole hour and ask me all the questions you want. Requests, you want to see new things in the API, let me know, because I don't want to be the guy inventing them all. I want to do stuff that you want to see. And again, some information here as to where you can find more info. We've got a wiki page on GitHub. All the samples are there. There's native reference, et cetera. And again, join us later. Thanks, everybody. And sorry for taking so much time.
Thanks, guys.
But the key thing to get here is that we have a good set of samples now that you can look at for all of these features.